Yeah, it's, I've done it. This is like my third round of doing Spark stuff. How'd you like it?
Yeah,
It's good.
so I came back.
This is a good sign.
But this is the first one, right? Under data table?
No, so this is the first one on Delta Lake. We've done 2 other Databricks and Spark ones so far.
Okay.
So this is, as we all know, it's the CLAM, Chicago Loop Azure Meetup. I, for some reason, picked an Oyster. Just want to say thanks to 10th Magnitude for providing the space and the food and the drinks.
Can you,
For sure.
can you try to remove that recording has started thing?
Great.
No, so that's only on the TV. And maybe,
No, it's on my recording too. There we go. Cool. Thanks, Tim, for doing that.
You're welcome. And then, so special thanks to 10th. We are over our mingling and food time because of technical TV difficulties. Promise, Databricks, Delta Lake, it will be easier. So who am I? Why am I talking to you? And why should you even listen? I'm Tim Arif. I'm one of the data architects here at 10th Magnitude. I am a Databricks partner champion, so I'm one of the few that's been, not few, there's like 100 of us in the country, I believe, who've actually been like trained and like certified and like had Databricks like validate that we know what we're talking about.
So do you contribute the code also on the Databricks?
No, that's pretty much all the Databricks employees. They have like armies of people who do that.
But the Delta table is like open source, right?
Correct.
Yeah.
So we'll be talking about Azure Databricks and Delta Lake. Before I really jump into it, who knows what Spark is? Does anybody not know what Spark is? Is the better question. Does anybody not know what Databricks is? Perfect. I will skip the next couple slides then, because there's always people who don't know those things typically. So just to kind of start, I want to just talk about like a Lambda architecture and how you have basically you have your streaming layer and you have your batch layer. So typically you kind of bring everything in through the batch and the streaming's there to kind of help offset the batch timing and get a nice flow going for queries at the end for the end user reporting. However, there's kind of an issue with that because you now essentially are paying for 2 different sets of infrastructure and architecture. And it gets a little costly, and then you have to have a few different knowledge bases of how you can do these things. And then Databricks kind of showed up and started kind of helping take the place of this in the cloud, where you would then start using like Data Factory. And then you basically use Databricks and the data warehouse or Data Explorer to kind of just interface with your data lake storages. But you still had a few different outputs of like infrastructure and costs and like where everything is at, who has to know what. And what Delta Lake is doing and
Is Lambda architecture all is just about having that multiple streaming and batch, and then you have a common source. Is that what?
correct.
Like,
Yeah, so Lambda architecture is around having, you have your streaming set of sources that funnel into your platform, and then you have your batch set of sources. So it's just the fact that you have both of those coming into one platform.
Okay.
Because more traditionally, platforms are all just batch loads. Like, hey, we have a bunch of infrastructure in our like office somewhere. Overnight, it's going to run a massive 5-hour SQL load. So these kind of architectures are trying to get the clients and customers, or even your own company, the end user of their data quicker. So Lambda architecture was the next like kind of logical step in this progression, where it's like, well, now we're starting to get like streaming. We have pub sub modeling. How can we get the data quicker while also still having our big batch loads overnight? So that's where having these 2 unison models that kind of come in and flow through the platform together like work. So if you see that like you have a streaming layer and a serving layer that all kind of get fetched up to the queries all at the same time through the same use. So throughout the day, the fresher data will slowly become more and more streaming, and then overnight batch will kind of take over again when it runs. And then throughout the day it becomes more and more streaming. So it's always 100% of the data all the time. And there's never like a lag, and you're not like, and it helps like kind of reduce them just having like a Kappa architecture where you're just paying for 100% streaming all the time. And most places would just kind of torch their bank accounts and kind of be like, why did I do this?
So it's mostly about, Lambda is just when you have the streaming and RDBMS data, or anything when you have a funnel kind of a structure, it's called Lambda.
Yeah, it's when
Lambda.
it's when you have like streaming and batch. Yeah, so it doesn't even have to be like a relational data model. It can be like still big, like NoSQL stores or any kind of like click data, anything that's coming in on like a hourly interval or a couple hours interview rather than something that's real time or near real time, because technically nothing's real time because it's all micro batches. And then so like and then as you got into Azure and like the cloud, you started having stuff where you would have Data Factory pulling stuff into Data Lake. You started having Databricks that could stream data into Data Lake. We still have this like Lambda architecture, and you're paying for like a lot of access stuff, and I think it's kind of a little hectic. What Delta Lake is trying to do, and there's one of the big things is there's always a lag between the joining of the sources, and what Delta Lake's goal is to remove that lag as well as kind of keep everybody's data up to date. So when anytime you interact with a streaming data source anywhere, you have to take into account it's streaming. It's not like a normal table. It's not a data frame. It's not a query. You have to treat it differently, because you can't just be like, hey, give me the count from this data frame. You would need to do a windowing exit to pull the data frame into a micro batch, and then you would do a count on the micro batch. So it's a little bit more complicated, and a lot of end users, once somebody gets the initial plumbing up, data analysts and folks, they're not going to want to be worrying about how to do a stream exit and pull data out from the stream or be able to peek at it. So what Delta does is you have your streaming and your batch data all right to one Delta table or multiple Delta tables, like however your model ends up working out. And everything down source from there doesn't care if it's a streaming data source. So once it's in the Delta table, even though it's streaming in 24/7, any queries you run in the Delta table would be acting as if it was a normal batch table. So you would be able to run a count on your Delta table and run it over and over and over and over again without doing a window streaming exit. And it would give you a different count every time. So you'd be able to like visually see the difference in how quickly like data was flowing into your table. And because of this, you're then allowed to join that onto the batch data with no differences. So you could stream a table, take a streaming data source, stream it into what we would call like an ingestion table or a bronze table. And then you could take a batch table, that like a batch data source that you would load into a different bronze table, and then you could join those together in a silver table with no special thought of the fact that one of those tables is streaming. And then even that silver table, as you refresh it, will always have that new data from the streaming table. So that's one of the benefits. That's my favorite benefit of Delta Lake. However, there are many more.
And what does Hadoop Azure data storage and
So-
S3 signify?
So you put the Delta Lake is open source, so you can layer that onto any of your data storages. So if you have Data Lake Gen 2 in Azure, you can layer it on there. If you just want to run it on the Delta Lake attached blob that comes with it, you can do that too. Not as recommended, because anybody who has access to your cluster would automatically get access to your blob, because everything's just going to end up in like the more of the root file. And if it's in the root, you can't really have access control or security management around it. So basically, if you have Databricks access, everybody's access to it, even though inside of Databricks and inside of normal storage layers, you can control the security aspects. So that way people can only access certain notebooks, people can only access certain folder structures inside of the data lakes or blobs. But if you use the root blob from Data Lake, which is the generic piece, everybody has access 24/7, which isn't a good idea. So with Delta Lake, the architecture seems still a little similar, but now you can see that the Delta and raw format are associated with Data Lake, and Databricks is going to and from the Data Lake storage at will now, rather than kind of having a one-way flow and like hoping your data is kind of staying in sync and having to worry about like extra exits from the data. On top of having Delta Lake, you also get ACID compliant, ACID transactions. You get time travel and a few other things.
I love that.
Yeah, the time travel is really cool. So I do have a demo that will walk through all these things with at the end. And then I did knowingly ask the Microsoft Databricks rep if I could use this notebook, and he said I could. And afterwards, I can share you all with this GitHub so you guys can pull it down and use it as well. So why?
Could you go back? I'm sorry.
Yeah, of course.
Okay, prep and okay.
Yeah, so that stuff is like, so the prep and train section is more in relation to data sciences, and as well as like just kind of prepping your data to go into the data warehouse or the data marts at the end. So when you're prepping, it's a lot more about the data modeling, and you have your training, which would be more in relation to your data science models.
So Delta Lake fits in the data lake,
Correct.
Yes.
right? Okay.
Yeah, so your Delta Lake is open source, and you can just layer that over any of your data storages that you currently have.
So isn't the Delta Lake almost like kind of another? It's weird to think of analogies. I'm thinking like almost like a SQL view on top of it, but it does more than what.
Yeah.
I mean, it's kind of I know it's a bad analogy, but
Yeah, so the way it works is, you're so jumping ahead of things.
sorry.
All right, you wait 1 second. So the ideal thing is it unifies batch and streaming, and it has a continuous data flow model. It has infinite retention. You can replay and reprocess historical events as needed. And it's independent. It's elastic compute and storage to scale. So it helps balance your costs. Meaning you could keep that on your storage only. It has no effect on anything. And everything inside your Delta Lake is still just a parquet file. So even if you're not using Spark and you have some other way of reading the parquets, you just lose the Delta Lake piece. So the Delta Lake generates a special metadata set inside of your folder structure that allows the Spark APIs to read it correctly, to know all the different like compliance and what the most recent JSONs, what the most recent parquets and everything are, which kind of comes into, I realized I had jumpy things in there, my bad team. So that comes into this stuff where with Delta Lake, you get ACID transactions, you get the version parquet files, you get efficient upsert, small file compaction, Z ordering, and time travel. The reason I'm kind of just blabbering buzzwords at everybody right now is because these are all extremely important and not stuff you would normally get with parquet files. So with parquet files, for those who don't know, is an immutable file. You can't make edits to it. Well, with Delta Lake, with the way it tracks transitioning and transition in history, you can essentially do that by it recreates the partitions, the parquet files for you, and just keeps track of it in the metadata. So you will, which then allows you to have full compliance history, because you then know all the changes that have happened to your parquet files, as well as you will then have a full time travel capability. Meaning, if I wanted to query data from 5 days ago, because we know for some reason our data today is super messed up, we track it back down, but well, 5 days ago when the IoT sensors just started blasting us with all sorts of junk. You can go query the data from back then as of that date and see what it looked like, so then you could get a full track on how everything's happening. So you can do a replay factor with some little extra like Spark work in there, where you can essentially smooth out that bad data then. So say you had like an oxygen sensor that's like out of whack in water, so the water is turbulent, so you now have tons of oxygen in there, and you know that's not accurate. So you would then run a smoothing algorithm on that during the replay, and you could fix all that data going forward, which would then smooth out and fix all your data for the rest of the queries. And like why this is important is because normally you would never be able to do that with parquet files. You would have to like manually track that and do it. And it was a pain. And Z ordering and partitioning has over 100 times performance compared to normal data skipping. So I'll get into that more when I get into the demo and kind of really walk through how it works. But typically when stuff is passing through and reading the different files, it's kind of just peeking at each file as fast as possible and seeing, is this the one I want? Is this the one I want? Well, with the Z ordering, it allows it to kind of basically reorders all the files physically and logically, so then you can then have the most optimal read times based off of the different columns. Kind of like an index, but not really, because of the way it works with data skipping. So the way you set it up would still be in a similar fashion, like index, column, sales name. And then when you query on it, it would come up faster. But with this, it's like physically moving everything around. And then it also allows you to have merge, deletes, and updates, which was normally not allowed inside of Parquet files. So how do you use Parquet? I mean Delta. You change your write from Parquet to Delta, and you're now using Delta, and it'll start using the APIs, correct?
The format is parquet file.
Yes.
Yeah.
So even if you read it with something that didn't have like the Delta formatting and Delta APIs, you would still be able to read everything. It would just come in as a Parquet. So you lose like some of your Z ordering and like time travel and everything, but those files are still there, still intact, and still the same way.
Okay.
You would just probably have a lot of them because it has all those old files from the history.
The versioning, yeah.
Yep. So the
Encapsulation.
Yeah. So the transaction log is how it kind of keeps track of everything. So if you see this, you can see the different commits that kind of come in with the Delta log. And those different versions of the JSON is what the Delta APIs will read in your Spark query. So it knows what the most recent Parquet file is, or it'll know what version to query when you're doing a time travel query.
So time traveling, I like, because it's event logging, right? I mean, essentially, that's what it is. Yeah.
So it's essentially event logging, and you can set it up to basically retain as much data, as much time as you possibly want. Obviously, you won't want to do too much because you basically would then have like 1, 2, 3, 4, 5, 6, 7, 8 times replica of data, which granted storage is the cheapest cost in clouds, but it would still get really expensive over time. So the tables and the logs help kind of track your metadata. They track if you've added files, if you removed files, and it just kind of keeps an up-to-date metadata list of what is happening. And the result of that is you have versioning history as well in Delta. So there's atomic commits, which basically means that you essentially get like a Git style repository where you're like, hey, I know what changed here. I know what changed here. This is what commit that happened when. And it also takes care of making sure of there's conflict. So if you have 2 Spark engineers working at the same time, it'll optimistically fix those. So that way, if 2 people check in at the same time, they'll know how to order it. I would love to be able to explain that to you, but I'm pretty sure that's some of Databricks' black magic voodoo they have inside of everything. And the way it kind of works is the users start off on the same files, and it kind of records the table version, records who reads and writes at what time. So if you read first and you read second, the second person reads second position, second. I keep saying second. It will then kind of track how those commits happen and basically time track everything and when everything falls into have a more optimal piece. And then it kind of keeps doing that over and over again to just make sure everything falls in sync and works correctly. And let's go to the demo. I want that on my screen and show. Oh, rookie mistake. I didn't start my cluster.
That's good.
Yeah.
So then it's really trippy. It's like really they're doing SQL transaction logging on top of all of the data lakes. I mean, it's brilliant. And so now you get all that stuff from classic SQL relational databases.
Yep. So you can
into it. So that's the power of those.
Yeah, and like right now, the only way you can do like merge. Why is that not turning on? 1 second. So right now, one of the things that's really large, I enjoy in it is like with Spark, you get the different APIs you can interact with it, and they're constantly just improving everything. So right now, the only way to do merge updates and deletes is with the SQL API. I think in a few months, they were like publicly talking about like they're gonna be having like a Scala, like a data frame API will then be able to do all that stuff too. So you won't even be forced to use the Spark API.
So what kind of use cases, like, is it mostly like a real-time systems, or do you recommend this for a batch processing, like I get the files once in a day?
So it's kind of my obsession right now, and I can usually find a way to hammer Spark and Delta Lake into anything. Okay. So it would all depend on what you're doing. So if you're just trying to do a standard star schema relational model, you have your data factory sucking in the data. By all means, just keep that data flowing right to the database. No need to drop it in a data lake. As soon as you start dropping stuff in a data lake, instantly I would suggest using Spark and using Delta Lake. Okay. Just because that will give you all the tracking, it helps optimize all the files. So one of the really cool things in here that I'm going to help demo is it optimizes files. So as data comes in, it doesn't necessarily always come in the proper data size. Okay. Some of your files would be like 200 megs, 500 megs, 800 megs, like 2 gigs, 6 gigs. Well, you can run optimized queries inside of Delta Lake that will then, because most of the cloud structures like Data Lake and Blob, the best optimal read size for the partition data inside of there is 1 gig. Okay. So if you run an optimized query on your data, it will go through and fix all those parquets to be 1 gig in size, so you have the most optimal read and write times.
Okay. So if I go for a data lake, I better go for the Delta Lake.
Yes. So you still use Data Lake Gen 2 or Blob or S3 or whatever you're using, but you would then have to layer Delta Lake over the top of it.
Storage is,
Yeah.
the storage would still be on S3 or SGFS or.
Yeah, so because all Delta Lake is like essentially like an open source API system for Spark to read from. And one of the big factors of using like stuff in like the big data ecosystems like Spark and Hadoop is there's a separation of compute to storage cost. So when you layer Delta Lake on top of this with the optimization patterns and the Z ordering and everything while interacting with the Spark already like is over 100 times faster than Hadoop. Even if you run Spark from file without using the cached memory, it's still 10 times plus faster than Hadoop. Now, when using this separate Delta Lake with this special Z ordering and optimizations, it's just like a no comparison now at this point, even if you're just reading everything from file and not even pulling it into memory. It just blows away like Hadoop out of the water now. So like even if you're just doing batch stuff, if you have people who know Spark and like Spark or Python or Scala, like I would definitely recommend that if you're not going directly to a database, to separate your compute from your storage and use Spark to do that. And then even if you're going to do like store procedures later down the road in your architecture, you can do all that stuff up front in Spark and pay a lot less. So at that point, you can just serve up all of your pre-modeled and calculated data to your database or data warehouse and just make sure it's allowed enough connections to it and you're paying drastically less for the compute power. Because with the databases and data warehouses, you're paying for that cost 24/7. To where Spark, you're only paying for the runtime aspect of it, and then your storage and data lakes like
Still,
25.
you can ingest to like a SQL data warehouse or somewhere, right? Because some of the users, they are pretty much used to seeing the SQL way, like a table structure, rather than because it's hard for them to connect to the parquet file.
Yeah, exactly. So that's why like it still pops up in a lot of the architectures. Like you can see here, like Databricks is still outputting to the data warehouse because there will always be some end user right now that's like, hey, I need to interact with this with SQL, especially now with like SQL data warehouse where you can interact with, Azure Synapse, where you can interact with it with T-SQL was one of the recent updates.
Yeah.
So like keeping that in line for a lot of the end users or the business analysts or systems analysts, data analysts is really beneficial. But all that upfront data engineering work now can be done in Spark using Delta Lake and save you a ton of money on all of your pipelines, even if it's just batch stuff.
Okay. Would we see in detail on Z partitioning?
Yes. So I always forget to turn my clusters on. And so I'll go into some fun facts about Databricks and their cluster systems. So the clusters typically on average take 5 to 7 minutes to start. So you have a couple different variations of clusters. Hey, it started. You have your interactive cluster, which is what I'm turning on, which takes the longest, about 5 to 7 minutes. You then have your job clusters, which have, I think, about 3 to 5 minutes start time. And those are more from when you're running like a cron job inside the Databricks. That will be a self-terminating cluster. So it'll run up, do this one very specific job, and then kill itself. So the cluster's gone, you're not paying for it. Then there's also basic light clusters, which are even smaller and cost less money. You will eventually, so you were saying you work at Northern Trust. One of the things that, like, depending what kind of financial data stuff you're calculating, there are companies that will just leave an interactive cluster on 24/7. So that way, as soon as that query is ready to come through, you have that data, you want to get the model out, you keep that on, you get the instant run of Spark, and then you're good to go. So they pay for that upfront interactive cluster, so they have that 24/7 availability of it. So let's kind of walk through here. So what we're going to be doing is using a data set of IoT sensors. So I ran this just to kind of look at the DBFS so we can see what's in there. So we just see a ton of JSON data. So we're going to read that as a data frame here. So just kind of calling the raw path and doing a read JSON from the raw path, and then we're going to display it out. So we'll go from seeing all these JSON materials to like a standard Spark data frame. I also spun up a very tiny cluster, so everything's going to take a little bit of time because clusters are very expensive.
Databricks, the cloud platform is Azure, or?
It's Azure and AWS right now. They only run there, and then they run on like all like the Gov clouds and like all that kind of stuff as well. So now we can see that just from like a simple read JSON, the JSON's not all read in as a data frame. It's a little bit more tabular and easy for us to view. So what we're going to do is we're going to write this data frame back to the storage and write in the Delta format.
So when you read a JSON, it automatically picks up the schema also?
Yes. So anytime you're reading batch, you can infer the schema. Anytime you're reading a batch anything, you can infer the schema. Anytime you're reading or writing a stream, you need to explicitly call the schema because it's a stream. It can't peek the entire file and then tell it to you because it's constantly streaming. Typically, you would want to call out the schemas just so you avoid any errors. In this kind of lab scenario, it's just quicker to not do that, especially since that's not like our focal point.
Mm-hmm.
So now we wrote the format of Delta. We just kind of literally just changing the word from parquet to Delta, and it writes. So let's kind of explore what happened. So we're going to do just ls and kind of look at all the different parquet files now. So before we had the JSON, and we went from JSON to data frame. And then from this data frame, we're writing back down to the Delta Lake, and we can see how it's the size of everything and the different parts of the files. So these are all parquet files now. We see the parts like 1 through 7 multiple times because there's different variations a little bit, and then just a kind of rough size. So you do see some of these sizes aren't the optimal piece, which we can fix later with optimize. And now with that, we get the transaction log that's kind of kicking into place. So let's just kind of create a table directly from the file. So by doing this, we would do just like a standard SQL API run instead of having a data frame API. It helps kind of work with just a lot of the people who are starting to tend to favor towards Spark are more SQL engineers, which is why the SQL APIs are kind of getting the initial set of everything. And with each of these kind of runs, each one kicks off about 5 to 6 jobs typically. So it takes a little bit of time because I have a tiny cluster. Because if you're ever testing this stuff, turn your clusters off. They're extremely expensive. I left the HD Insight cluster on one time and I ran out of my Azure credits within like overnight. Like I woke up and like, your stuff's disabled. It's like, I just had a refresh. Oh, left the cluster on.
Okay.
And Microsoft very rarely refunds you that money. So if you have a subscription set up to your account with like a credit card, they'll just charge you away. I knew somebody who left one on and like ended up losing $5,000. Yeah.
Did he get a refund?
No.
No way.
So now,
Responsible.
yeah, pretty much.
It's just crazy. Yeah.
Yeah, you just gotta make sure you turn all clusters off, especially if you're playing with streaming. So Databricks has a fun functionality where you have a self-terminating cluster due to inactivity. If you have a stream on, even if it's not reading anything, it's still using compute power, meaning the cluster is not inactive. It will not turn off.
Okay.
You have to terminate the cluster at that point. Or you can stop the job and then wait for the inactive cluster to kick off, but at that point you should just terminate. So now we can kind of read. So now we're reading this raw table that came back in from Delta, and all seems the same. To read in 3.54 seconds. So now with the fact that it's Delta, we can now append records to it. And here we just have like a quick sequential JSON that we're going to append up. So we're going to write it out, convert it to a data frame, and then start to append it. So this will be the initial generation of the record. And here, all we do is write format Delta, append, and then you save the table back as is. Why didn't that work? So Delta Lake has a schema enforcement. So as big data stuff changes, you're not just going to start overwriting all your old data. You won't just kind of lose your schema. It'll take care of that. It will handle your schema changes, let you know when there's a conflict, because sometimes data will spit out just lots of problems. If people have worked with Spark, you've probably seen the full null data frames many times. And it's just like, why are you null? Oh my God. And this kind of helps take care of that, because as soon as this happens, you can essentially put it back to a dead letter queue and basically be like, hey, we need an engineer to come check this out and see why this broke, why is this happening. You can force schema merges and updates as well, which would be a little more cautious about doing, especially in like a streaming environment, because data will come in weirdly, and then if you force it to overwrite, it will then overwrite a lot of stuff you don't want, and then you'll be back dealing with time traveling and trying to figure out how to write some new data frame queries to fix everything. And so we were able to just write the format append in the data frame API. We can also do it in SQL, where you just kind of go standard like ANSI SQL, insert into the values. And now, even though it's, would potentially have a streaming source or a batch source, we're able to just count it. Like, doesn't matter like what the source is, as long as you're reading from a Delta table, you can always count. And if we had a streaming source on here, we would literally just be able to shift enter constantly and just see a new count every time. So now we're going to start a stream reader to the table, so we can then we'll continuously like check out the files to then kind of watch what's happening as we have the batch data already there with the streaming data flowing into it. Okay, so yeah, still good on time because you said you're leaving kind of early. Perfect.
So here's your Lambda, right?
Well, not anymore.
I know.
More the Delta architecture.
Scroll up a little. Okay.
Yeah, so you can.
Okay, so we are doing a read stream.
Yeah.
Write stream.
Yeah, so we're just writing this in the output mode amend, and we're going to the Delta table here of the streaming devices. So now here we're going to display the stream. So Spark read stream from the Delta table. And let's add some rows to see if they get processed right away. So we just added the new record to the device raw table, which I'm losing my, oh, this is all about concurrency, sorry. So that, all that does is showing that you can have all the streams and writes and reads all at the same time, as long as you have the executors available. So now we can do upserts and updates based off of like kind of what data is coming in. So let's do this SQL statement. We're kind of selecting the different CO2 levels and the device names and timestamps from the different countries. And now we can kind of check out what's going on. So we see the United States, it's throwing the CO2 way out of whack. Well, that's not correct. So let's go fix that. So we're going to kind of come in here and say, anywhere where the device raw is equal to divided by 1.8. So anywhere there's United States, we're dividing that number so we can, the United States look like we actually do our green part. So now when we do the query again and look at it, we'll see a much different story. Much better. The US is in line with everything now, which only was the truth. So now you have a issue where there's different people at your company going, why did we just edit this entire data set? Like, why did that happen? So now we can describe the history of it. So in a normal Parquet file or data lake, you wouldn't have this. So we can kind of come through here. We can see create table. Why do we update this? Here's the update, the notebook ID, the cluster ID, and who did it. So now we can see I decided to come through and update it, which you wouldn't normally get with any kind of data lakes or blob storages. It would just kind of be a free-for-all. And whatever governance you're able to enact with like Active Directory or IAM controls in AWS is what you would have. So now we can track everything. Then you can kind of figure out why people are doing things or just kind of have a better control around it, which then helps with your security team and make sure you have a better auditing practice in place. Well, with time travel, of course, things break. Hey. I may have to update that time. Live demos, things always break. So essentially what we're trying to do is set up the time travel query so we can look at the data beforehand, so go back and fix it. So what I did was I'm doing a query on the device where the timestamp is of what date. So I grabbed the timestamp before the update, and I'm running the query. So now we can see the US is back to normal of its terrible polluting self. So we're going to go through and merge the statement into Delta where we kind of.
And the timestamp value is added by the Delta Lake is not part of the actual data, right?
Correct, it's just part of metadata.
Yeah.
So if you were to still come in with a different Spark app, say you had Spark running Kubernetes without the Delta APIs, that Spark would still be able to read from the data lake as is. You would just get a ton of data because there would be, say you had 3 days worth of data per your Delta Lake store, and anything after 3 days is deleted. Your other Spark queries wouldn't know how to read the metadata, so it would be reading all 3 days as if it's a whole set of data. So you essentially have multiple duplicates based off of it. So you would have to run some like distinct to kind of remove everything to make that work. A little annoying, but like it's something you
So
can
it might
do.
be Z partitioning on the timestamp.
Not necessarily. We'll get into that.
Yeah.
So once you go to Delta Lake, you can't go back.
Yeah, I love Delta Lake.
It's something that you call vacuum at once?
Yep, and so vacuum is what keeps track, removes all the extra days.
Yeah.
So if you say you set your vacuum to 7 days, which is typically what you would want to do because your Kafka event hub or any of your pub submodels typically have a 7-day retention policy. So you would match Delta Lake to that, so that way you would never have anything that you could accidentally run out of sync. So we're kind of set.
What's vacuum here?
So what vacuum does is what you would call inside of the Delta Lake. And essentially, so say you want to only store 7 days worth of timestamp
Retention
data.
is 7 days.
Yes, so they call it vacuum. So when you run the vacuum command,
Okay.
or you set an automated vacuum command, every time something goes beyond that date, it gets removed.
Okay. So vacuum is basically purging all the data
Yeah.
which is older than your retention policy.
Correct.
Okay.
So
Cool. Vacuum.
It's like everything you want, right?
yep,
Yeah.
it makes it so easy. They have a command called optimize where you basically go, I have a ton of tiny files, optimize, and it just starts
Compaction.
it compacts or it'll depact to try and bring everything to a 1 gig file size, so your partitioning will have the fastest read writes possible. It is wonderful and is always necessary, especially when you're pulling in a lot of files, because you may get like, say you're reading something from weather data, that stuff's always going to be tiny. Like we're talking like kilobytes, maybe megabytes if you have a ton of it. So over time, that you can compact those into larger files, and it's all automated because you just run your optimize query and it'll start optimizing your entire Delta Lake for you automatically.
We need something like that on HDFS. Optimize.
Yes, we do. That's why I tell everybody to go to Spark now. Even before it, just due to how much faster it runs and does the compute, it just blows it out of the water. Because even like a on-disk Hadoop cluster, so Hadoop always reads from on-disk. Spark, even if you did all the reading from on-disk, still runs over 10 times faster. And then when you add Delta into it, it runs well over 10 times faster than Hadoop or Hive or any of that kind of stuff. All right, so what we did was just kind of set up a new table for a new data set as we kind of go through, and we're doing some merging into it now. So before, all we did was update and append the tables, which on the back end are still just Parquet files in a Delta Lake. But because of the way everything's working with Delta, we interact with it like with a normal table. So it has a very nice like relational feel to it. So let's kind of query the data, make sure we have it. So now with just merging, we can go in and update these values. So just doing like a normal merge statement like you would run in Nancy SQL. On this, when this matches, update this. When not matched, do a full insert. So, oops. Let's run a SQL command to just query it. So now we can see that we added the hello worlds in here. And for those who ever have to deal with GDPR, there are ways to purge and delete everything. So you will always be, you can say in GDPR compliance, which is pretty large. And even if you don't need to be in GDPR compliance, probably a good idea to just get in the habit of it because it is good practices. because it maintains the history, we're able to delete the deletion of records, which you normally can't do in SQL. So even though on the back end, all it's doing is inserting a new partition, but when you run a delete command, it's basically just grabbing that old file with only the records you want besides the one you're calling to delete, and then it saves a new parquet file.
Okay.
And with the metadata that would read off of from the Delta's metadata that's inside of your Delta Lake, the Spark APIs would read and know that the most recent file with the deleted data is what you want to read. So to everybody, it feels like you're just deleting data, even though it's just making a new Parquet file.
Okay.
And you can do the merges as well. So if you ever match data, say you ever need to do like, as we're querying data, say we have a master user list, and somehow somebody re-enters my name into that user list. I can delete myself then, or you can run, that's a terrible example. It'd be like if you're tracking time and somebody changes your time tracking and now you have a different time code. If it matched the old time code, it would delete out and your new time code can come in then correctly. You can kind of get creative with how it works. And let's now take a look after we deleted some of the devices out. So now that we ran the delete command, we now no longer have the hello world 2s in here at the top. Oops, I'm doing lots of scrolling. Right here. Yeah, so now we just have hello world stream. We don't have the batch hello worlds anymore. Now, Z ordering and partitioning and how it works. So when you do the file compaction with the optimize, you would then be able to call a Z order. So you'd be able to optimize events based off a timestamp and an interval of 1 day. So you could be like, hey, for the past day, because we've already optimized days 7 through 6. We have a new day's worth of data at the end of the day. Let's optimize that and get it all compacted correctly. You can then Z order that by one of the different fields inside of it. So normally, if you look, you would have like more of a linear order search. So you would scan 9+ files, and then if you do a Z order with the way it restructures the formatting, you would scan 7 files. So not only is it a quicker read and write, there I can zoom in maybe if I know how to use a Mac correctly. Nope, nope, nope. That's a new tab. Yeah, no idea.
Command plus doesn't work.
I have no idea. I literally don't use Macs much, and when I do at home, I have a different keyboard that doesn't have all the Mac stuff on it. So you can now kind of see this, but like, so basically it reduces the amount of files scanned. So you get less false positives of the data you're looking for, which then reduces the cost of compute. So running this up front as you do it saves you money. And when you're running in the cloud and everything's very cost effective, like not very cost effective, having as much ways to save money and time is extremely important. Any questions?
I didn't totally understand the Z order partitioning. So
Z order co-locates information in the same set of files that allows a dating skipping algorithm to reduce the amount of time that needs to be read. So normally you would have that linear order, which is on the left. So you kind of scan through all the files going like essentially like more of a very linear manner where you're just going left to right. When you do a Z ordering, it restructures that file to allow you to have a quicker read. So instead of like kind of, you would read across, say you did a linear read. Even if you just came all the way across here, you're reading 4 files compared to your 2 files. Yeah. So the search algorithm is able to hit more files quickly and find the data you're looking for. And that way, as soon as you get all your data, you're scanning less files and you're doing less work and you have better computation.
So kind of like a binary search.
Essentially. That's weird. I didn't run this recently. I guess I did. 6:30.
It's working on high cardinality columns and then bringing co-locating the
so
same cardinality data.
Correctly. So it helps. Like the way to think of it is, it's more when you're partitioning data, you want to try and have the partition set up to be in the most equal manner. And when you run the optimize, it essentially takes care of all that work for you. So you do the optimize with the Z ordering. Not only will it compact the data into larger files to be about 1 gig each, or smaller files if it's a larger file. will also you can then Z order on the column. So when Z orders on a column, it basically will then alter those Parquet files going forward. So you have a better like storage system so you can read everything quicker. But to the end user, when you're using Delta Lake, it's all essentially just like a standard indexing strategy that you use in like a SQL server. So let's read from the taxi data. So we're going to write the taxi data as Parquet and Delta, and we're going to compare the two. We may fall asleep during this. I am sorry. So for those,
It's hot in here.
it is really hot in here.
Yeah.
For those who aren't very familiar with Spark, the reason this is taking so long is because I have a really small cluster. So as the job works, there's only so much memory and executors that can run. So essentially, it's having to run on one executor or two executors. Like it keeps repeating itself until it can finish the job and process all the data. Normally, when you're running Spark jobs, you want to have each in-memory partition per Spark executor at 200 megabytes. So you take your total size, you divide that by your target size, which is 200 megs, and that tells you how many cores you need, which would then essentially act as a Spark executor. So you have one core per partition on your Spark cluster, and each of those executors will be able to run through that in one complete run. And you want to try and stay on the most even number possible. So that way, if you're running your cluster, you're paying for your cluster. So if you're running at 85% usage, you're losing 15% of that cluster's costs because you're not leveraging it. So if you're coming in at like a weird size where it's like you would have like 143.5, you kind of got to find the denominator to where you would then run that process twice over on all the cores. So you're at 100% usage constantly. The goal is to optimize the amount of memory usage per your Spark cores. So that way you get all your money's worth. Unlike in like a SQL server where when you start getting to like 80% usage, you're like, oh God, we need more memory, allocate more stuff. People are killing my database. What's happening? Well, in Spark clusters, when you're running, especially in a production environment, it's all about maximizing that workload to 100% usage of your cores. And because I have a tiny workload and I'm doing a lot of things, it's taking forever. I mean, a tiny cluster. Any questions, thoughts, comments, concerns? Y'all in love with Spark now? You drink the Kool-Aid like I did?
Does Delta use Parquet underlying? It should.
Does what?
Parquet, does Delta underlying like under the hood it uses Parquet, right? It brings a lot of optimization.
So Delta,
like the Delta format, when we say format Delta.
yeah, so that is literally just metadata. So the only way to interact with Delta is via Spark. So it's an API call essentially that would happen. And you kind of take care and write all this metadata. So when your Spark would go to read the stuff, it would check this metadata first. And depending what the metadata says, it knows what to then query. But to you, it looks like you're just querying the one taxi cab table, and then you don't care how many times it's in there based off of how many days. The metadata from the Delta Lake will always give you the most recent one unless you explicitly do the time traveling.
Mm-hmm. I mean, when you write it to a S3 or blob, it looks like the files would look as .parquet.
Yes, they're all Parquet.
All Parquet.
So you could still read it from a different Spark cluster, however else you feel like reading Parquet. Yeah. But you would just have lots of the duplicated data. So you would have the amount of data per the amount of days that you have your vacuum set to multiplied in that read. So you would have to get a little more specific.
So if I use these Parquet files outside the Delta Lake, then I would have to take care of the dedupe and everything.
Correct.
Okay.
So we finally got the cabs right. Let's run this. We're kind of reading the Parquet format. What's kind of fun about this is the fact that it takes forever. It is a small data set, so the optimization piece of it and the querying of Delta will be quicker. It's just not like oh my God, so much faster, because I only have so much credit that I'm willing to spend. I guess I can close this extra tab I accidentally opened while trying to zoom. So is anybody currently using Spark, like on a day-to-day basis? You are?
Yep.
Yeah. Have you drank the Kool-Aid then?
I'm drinking the beer.
So we can see that took 44.42 seconds. So we're going to drop that, create it, and then optimize it. So what we did before initially was, this is all from the Parquet files. So what we're going to do is we're dropping the tables, we're creating the table from the Delta location, and then we're going to optimize and Z-order it. So we have 44 seconds. Once this is done, we're going to rerun this query, and that's going to be reading from the same data set just to show the latency difference in the two. Yeah. And that's still as if it's coming from Parquet, not even calling it a Delta file.
Okay, so you are specifying the field value, payment type, when you Z-order it.
Yep. And for those who do use Databricks or are trying to get into it, if you hate the notebook style writing, which a lot of data engineers do, there's DB Connect you can use now. So you can write into it, like you can set up DB Connect on your computer and use IntelliJ or PyCharm or any ID or like Visual Studio Code even to write everything. And you can just push it from there to your cluster so you don't have to do the notebook writing.
Okay. So how do you connect from the IntelliJ to the, you can connect to the Databricks?
Yes.
Because we are trying to use IntelliJ.
So if you're using IntelliJ to connect to Databricks, you go through and set up what is called DB Connect. So you have to go install a couple different repositories essentially that help then give you the ways to have like the proper Spark versions, the proper runtimes. You make sure you install the correct stuff with the clusters you're running, and then you would pass in your Azure credentials into your IntelliJ area, and then it would run. Then you can connect to it.
Right now we're creating a jar file and moving it into the Databricks and.
So that's what you would do for like a production deployment.
Yeah.
But if you're just trying to like test stuff and you like. Yeah, that's, you definitely want to use DB Connect, and then you would type everything in IntelliJ and you can push it directly to it. Well, I guess it's running, so you can just type in Databricks, DB Connect. Make sure you're on the whatever cloud version, so if you're Azure, make sure you're on the Azure documentation. Basically, if you follow this setup,
Okay.
it will literally walk you through.
Yeah,
I've done it before.
Okay.
It works. It's kind of weird. So it's gonna be like telling you like uninstall your PySpark and do some weird things. You'd be like, I don't trust you. You're like a random web documentation. If you actually follow it and finish it, it will work and it will run.
Oh, sure. Yes.
And it's just called Databricks Connect or DB Connect. Nice. So now we got that. Let's rerun command 73. So it took 44 seconds before. Let's check it out. Anybody fall asleep yet? There it is. We're at 30 seconds now, essentially 29.12. And that's still just reading as a Parquet. So let's check it out when we read things as the Delta. $30 seconds, 4 seconds. So even just optimizing it still updates your read times from the Parquets because it's a physical thing. But when you still read as a Delta, it is just because it's reading the metadata, it knows how to find everything quicker, and it really does find it quicker. And this is a small data set. So the larger the data sets you get, the larger that Delta will be. God, Delta is now a terrible term to use. It's just like data warehouse. It's used everywhere. So the difference between the times to read and write of the two different styles will get larger and larger based off the more data you have. And you get your ACID transaction guarantee. So you get concurrency and isolation levels. It if you're dropping stuff into data lakes, storage accounts, file storage, it's just a wonderful product to use. I don't even work for Databricks. I'm not even trying to pitch it. I'm literally just pitching it because it is a great product, and I wish everybody would switch over to it. And then just like the key features of it is like literally just this list. That took forever. Like the adds to transactions, the scalable metadata handling, time travel. It's open sourced. Like you can unify your batch and streaming. You have schema enforcement. You have schema evolution. So you can choose to have a rigid schema. You can choose to let it evolve over time. It has an audit history. You can update and delete, and it's compatible with Apache Spark APIs.
That's good.
And the benefits are just kind of reduces your end-to-end pipeline SLA, helps organize and reduce pipeline SLAs from days and hours to minutes, reduces your pipeline maintenance and burden because it's all in one section, eliminates your Lambda architecture from latency use cases. It handles updates and deletes easily, helps with change data capture, GDPR, deduping, and lowers your infrastructure costs with elastic and independent compute. And that's the end. And I think I sped it up just enough for you, buddy.
Thank you very much. Yeah.
Thanks,
Did you get
Jim.
this presentation or something?
So the GitHub link to get that notebook.
Okay.
If you go, you can just Google GitHub Kyle Weller. That is one of the Databricks folks from Microsoft.
Okay.
And he has, if you look at his repos, you can just select Azure Databricks, and then they'll have that demo I just walked through.
Kyle
Weller.
Okay.
Yeah, his GitHub is KYE665.
Okay. Maybe I'll take the picture.